Okay, we're going to see question number 6. That is from exercise 7.4. The question is diagonal AC and BD of the quadrilateral ABCD intersect each other at O. Prove that AB plus BC plus CD plus DA is greater than AC plus BD. That means sum of the four sides of the quadrilateral ABCD you have to show greater than the sum of the diagonal. And number 2 is you have to show sum of the four sides AB, BC, CD, DA is less than twice the sum of diagonal AC and BD. Okay, so the ABCD is a quadrilateral and the diagonal AC and BD intersect at O. Let's write the given. Given is ABCD is a quadrilateral and AC and BD AC and BD intersect at O. Now to prove what? Number 1, AB plus BC plus CD plus DA greater than AC plus BD. Number 2, AB plus BC plus CD plus DA less than 2 AC plus BD. Okay, proof. Now, on the left hand side, we need AC and BD. If you see AC is a part of the triangle ABC, and AC is also part of the triangle ADC. So one by one, we'll take both the triangle. In triangle ABC, what you can take? AB plus BC greater than AC. Again, in triangle ADC, if you take the triangle ADC, you can take AD or DA plus CD, DA plus CD greater than AC. Okay, now how to get a diagonal BD? BD is a part of the triangle ABD and BD is a part of the triangle BCD. So we'll take both this triangle and we'll try to get BD. Now in triangle BAD, you can take what? AB plus AD or DA greater than BD. Now again BD we can get it from the triangle BCD also. Now we'll take the triangle BCD. But you can take BC plus CD greater than BD. We can mark it 1, 2, 3, 4, and the reason will be what? Sum of any two sides of a triangle is greater than the side. Now, if we add this 4 equation, what we'll get on the left hand side, we'll get AC, we'll get if we add this 4 equation together, on the right hand side, we'll get AC and BD. And on the left hand side, we'll get the 4 side of the quadrilateral. So let's add it and see what we get. Now I need to rub the first portion or first part. So I'm rubbing it. Adding 1, 2, 3, and 4. Now, if you're adding the 4 equation together, on the left hand side, we'll add it together. AB plus BC plus DA plus CD plus AB plus DA plus BC plus CD will be greater than AC plus AC plus BD plus BD. Now, if you see the left hand side, we have 2AB, 2BC, 2DA, and 2CD. So we can write 2AB plus 2BC plus 2CD plus 2DA greater than, on the right hand side we have 2AC plus 2BD. Okay, in the next step what you can do, we can take 2 common on the left side. And if you take 2 common, whatever is left you will write inside a bracket. Again, on the right hand side also we have 2 in both, so take 2 common and whatever is left right inside a bracket. And after taking common, what you can do, we can cut 2. So what is left? AB plus BC plus CD plus DA greater than AC plus BD, and that is what you have to prove in 1. Now we'll show the number 2 proof. Okay, I will rub this because I need space. Okay, number 2 proof. In the number 2, what do you have to show? Again, you have to show sum of the 4 side is less than 2 twice the sum of the diagonals. Okay, now look, now to show the number 2 proof, we're going to take this 4 triangle AOB, BOC, COD, and AOD. That means we're going to take 1, 2, 3, 4 triangles. Now in triangle, first we'll take the AOB, and in triangle AOB, if you see nicely, AO and BO are the part of the diagonal. So we'll take them together on one side, and the side of the quadrilateral AB will take on the other side. So what you can take, we can take AB less than AO plus BO. Okay. Sum of the 2 sides is greater than third side, or a single side will be less than sum of the 2 sides in a triangle. Again, in triangle BOC, if we take the second triangle BOC, again BO and CO are part of the diagonal, so we'll keep it on one side, and the side of the quadrilateral BC we'll keep on the other side. We know what sum of the any 2 side is greater than third side, or a single side will be less than the sum of the other 2 sides. So what you can take, we can take BC less than BO plus CO. Again, in triangle COD. In triangle COD, again, if you say CO and DO are part of the diagonals and CD is a part of the quadrilateral, so what are you going to take? CD less than CO plus DO. Then again in triangle AOD, again in AOD, AO and DO are part of the triangle. Sorry, AO and DO are part of the diagonal, and AD is a part of the quadrilateral. So what are you going to take? AD less than AO plus DO. So all the part of the diagonal we are keeping on the right side, and all the part of the quadrilateral ABCD I'm keeping it on the left. Okay, instead of AD, we're going to take it as DA, because in the proof it is written DA. Now we can mark it 1, 2, 3, 4. And the reason will be same for all of this, so we can write it together. We can write same reason, sum of any two sides of a triangle is greater than left side. Now what are you going to do? We'll add this four equation. Now if you add this four equation together on the left hand side, what we'll get? All the left hand side will add with the left hand side, all the right hand side will add with the right hand side. All the left hand side of the equation we are adding with the left hand side, all the right hand side of the equation we are adding with the right hand side. So we're getting AB plus BC plus CD plus DA on the left, and on the right hand side we know what AO plus OC. AO plus OC is AC, plus again AO plus OC will be AC, and BO plus BO plus DO is BD, plus again BO plus DO is BD. On doing that, what are you getting? AB plus BC plus CD plus DA. We're getting greater than, less than. AC, how many AC? Two of them is there, so add it together. BD, how many? Two of them, add it together. Okay, I need some space, so I'll write it. I'll be rubbing the first part. Now what are you getting? AB plus BC plus CD plus DA less than. On the right hand side, we have two inputs, so we can take two common. We'll get AC plus BD. Was it? And that is what you're asked to prove. And we can write hence proof. Okay, next we'll see question number 7. So that all line segment drawn from a given point not on it, the perpendicular line segment is the shortest. Okay. So there is a line segment AB. Of all the line segment drawn from a point, so there is a point, say O, and from that point there is a perpendicular, say OP. Yes, and say there is another point Q. And what you have to show, we have to show that OP is the shortest line segment. Okay, so question number 7 given is what? AB is a line segment. And O is a point on, O is a point not on AB. And OP is perpendicular to AB. Now to prove what OP is there. To prove what OP is the shortest line segment from O to AB. Okay, to prove this, we need construction. We'll take a point Q on AB and join OQ. So we'll take a point Q on AB and we'll join this OQ. Okay, proof. Okay, now if you see on joining OQ, we are getting a triangle. And in a triangle, if one angle is 90, the other two angles are equal. This angle, say, if you mark it 1, angle 1 is equal. So angle 1 will be less than 90. Angle, we can mark this one as 2. Angle 2 is 90. So in triangle OPQ, if you see the triangle OPQ, angle 2 is 90. So angle 1 will be acute. So what you can take angle 2 greater than, or we can take angle 1 less than angle 2. Okay, before that. So first, let's take angle 2 equal to 90. We know it will be 90. Why? Since OP is perpendicular to AB. So angle 1 will be less than angle 2. Why? Since angle 1 is acute. Now, opposite to angle 1 is OP. So OP will be less than, opposite to angle 2 is OQ. Opposite to angle 1 is OP. Opposite to angle 2 is the line OQ. So OP will be less than OQ. So what you are showing is OP is less than OQ. Similarly, we can show OP is less than any other line segment drawn from O to AB. Similarly, we can show OP is shorter than any other line segment drawn from O to AB. Okay, I need some space, so I'll rub the first part. So from this we can conclude what OP is the shortest line segment from O to